All right, guys. Hey, we've got some stuff from Algebra 1 to talk about today. Yes, that's right. I told you that calculus is the culmination of Algebra 1, Geometry, Algebra 2, and Trig pre-calc. And so today what we're going to be doing is some Algebra 1 stuff. This should look really familiar, but make sure you don't mix up one or the other. Make sure you remember what all of those variables stand for. Have some stuff for you to copy down here. How do you write the equation of a tangent line to a given x value in a function? So here are the steps that we're going to follow for example number 1. First of all, you find the point. You need to figure out what point the tangent line intersects the original graph. So like for this one, we're going to take x equals 1, and we're going to plug it into the function to figure out what the y value is. That's step 1. Because in order to write the equation of a line, you need a point and a slope. So we got to find the point first. The second one is to find the slope. That's what we learned yesterday. To find the slope, what you do is you plug in the x value you're given, so x equals 1, to the derivative. And so just remember that the derivative, the symbol notation for that, the most common one is that f prime of x. So be really, really careful in looking to be very sure that you know that this is the original function and this is the derivative. Okay, and then once you have a point and a slope, you're able to use your Algebra 1 skills to write the equation of the line. Okay, we're going to go right into example number 1. So it says find f prime of 1 and write the equation of the tangent line to f of x at x equals 1. So following our steps that I wrote up here, the first thing we're going to do is find the point by plugging in the x value to the equation of the original function that we're given. So step 1, find the point. I'm going to plug in 1 to f of x. So that means f of 1 equals 1 squared minus 3, 1 plus 1, which is negative 1. Okay, that point is what I'm going to use when I write my equation. So just remember that you know the difference between the x and the y. That means when I plugged in 1, the answer, the y value I got was negative 1. So that is the point that I'm going to use and I'm going to need to write the equation of my line. Second thing I need to do is figure out what's the slope. And so what I have written up here is to find the slope. That means that you plug the x value into the derivative. So here's the derivative. So I need to plug in this x equals 1. It's also written right here, x equals 1, into the derivative to figure out what the slope is. So f prime of 1 is, I'm using this equation now because this is the derivative, 2 times 1 minus 3, which happens to be negative 1 also. So that is the slope. That's the other thing that I needed in order to write the equation of the line. And so step 3, now that I have a point and a slope, I'm going to use the y point slope formula from above, which is y minus y1, and my y1 is right here, which is negative 1. So minus negative 1. I do write minus negative and then I change it to positive afterwards because I can never remember if I changed it or if I forgot to change it or whatever. So I will change that to a positive 1 in just a second. Okay, so the slope is negative 1, and then you do x minus the x value, and the x value is positive 1 here. So this means y plus 1 equals negative 1x plus 1 when you distribute that. Be careful with your negatives. And then subtract the 1 over, and you get y equals negative x plus 0. No, you do not need to write the plus 0, so here's the equation of the tangent line to this graph. Here's a little bit of a visual for you guys, is that you know this original equation here is a parabola, and it's an upwards facing parabola, so it looks something like this. And I already figured out that the point 1 comma negative 1 was on the graph, so that's somewhere like right here. Cool. And I have a tangent line, which has a negative slope that looks something like that. And this equation of the tangent line is y equals negative x. And so this is like all what we're trying to figure out here, is keep in mind that you should have a visual that goes with all of this. You have an original function, which is a parabola, and then we also have this equation of the tangent line, which is the equation of the line that touches that parabola in only one location. And this point right here is the point that I found in step 1. It's 1 comma negative 1. Okay, let's try another one. Here we have example 2. It's again f prime of 1, x equals 1. That's just coincidence that they're using x equals 1. The x value could be anything. But what I'm going to do first is I am going to figure out what the point is. So step 1 is to find the point by plugging in f. Oops, this is h actually. And it's h of 1 is what they want me to plug in. So I'm plugging in the 1 right there. 2 ln of 1, type that in your calculator, or remember from algebra 2 that you can't log 1, or that you can log 1, it's just 0, so 2 times 0 equals 0. That's the y value. Remember, that gives you the point. When you plug in 1, you get 0. So this is the point that I'm going to use in my point slope formula. Okay, step 2 is to find the slope. And that means find h prime of 1 and pay really close attention. This is h prime. This is regular h. This is h prime right here. Okay, so what I'm going to do is I'm going to plug in the 1 to h prime of x. That gives me 2. That is my slope. So I'm like trying to keep track of all the important information that I found here. Step 3, now that I have a point and a slope, I can use my algebra 1 skills to do y minus the y value equals the slope times x minus the x value. And all I have to do is clean this up a little bit, so I get y equals 2x minus 2. Don't forget I distributed that and the 0 doesn't matter, okay? All right, moving on to part 2. So we've got this crazy looking equation here, and we have to answer a bunch of questions about it. So very first one is that, just pay close attention, this right here is the graph of the original function g of x, and it's asking us stuff about g prime. So that's a little bit weird, but if you remember that the value of g prime at a certain number happens to be the slope at x equals -6. So I think we can probably look at the graph and find x equals -6, and you'll notice that I already drew like where the line is right here at x equals -6. Can I figure out what the slope of this line is? This line, you go down 1, 2, 3, and then over 2. That's a -3/2 slope. So -3/2. How about the value of g prime of 1? That means the slope at x equals 1. Okay, so I'm going to go over here to x equals 1. I already drew a dot there. Here's x equals 1. Can I figure out what the slope of this part of the function is? So that means I went up 1, 2, and then over 1, 2, 3. So that's positive 2/3. This is algebra 1, you guys. This is awesome. Okay, the value of g prime of 7. This means the slope at x equals 7. You got to get the lingo down to be successful in calculus here. Okay, so here's x equals 7. Again, I already drew the line that goes through x equals 7. This is a horizontal line. The slope here is 0. It is completely flat. That is the kind of treadmill I enjoy running on when the slope or the incline is at 0. It is flat. Okay, so here the slope is 0. So I answered those first 3 questions. Part D says write the equation of the tangent line at x equals -6. So again, to write the equation of the tangent line, I need 2 things. I need a point and I need a slope. So first I need the point, and that means I need to find f of -6. And so I don't have an equation to plug -6 into, but I have a graph to look at. And it looks like the equation of -6, or the graph at -6, 1, 2, I can't really tell. Is that up like 2.5? Is it a little bit more than 2.5 or less than 2.5? I'm not really sure. So here's a tip for you. Pick an easy point that's on this section of the graph. Okay, so any point on this line will work. You should remember that from algebra 1 as well. It doesn't matter what point you pick as long as it's on the line. So you could pick this one. This is -7, 4, or you could pick this one, -5, 1. That one I'm not exactly sure how high up it goes. Let's look at this point. This one would be easiest. So -5, 1 is the point that I'm going to use. -5, 1. Pick an easy point, not one that has like fractions and decimals and stuff, okay? Step 2, I need the slope. I already answered that question above. The slope at that point, x equals -6, was -3/2. Now all I have to do is write the equation of the line. Y minus the y value equals the slope, x minus the x value. And yes, that double negative changes to a positive. Yes, you could distribute this if the directions said leave it in y-intercept form, or I don't really feel like distributing that fraction, so I'm going to leave it like that. Next question says find the equation of the tangent line at x equals 1. Okay, so what's f of 1? I just realized these are all g's. Dang it. These should be g's. Same up here. Don't get confused. They name the equations a very specific way. So let's look at g equals 1. At g equals 1, again, I'm not sure how high up this point is, so pick any point on this part of the graph right here because the slope is the exact same for all the points that make this part. I don't want to use that one because I don't know exactly how high up it goes. I'm going to use this one, 2, 3. That would be much easier to use than a decimal. So I'm going to use 2, 3. Part 2, what was the slope there? I already answered that question. The slope was up 2 over 3. And so part 3 is to write the equation of the line. Y minus the y value equals 2/3 x minus the x value. You could distribute that if you wanted to. Again, it would get a little bit messy with the fraction, so let's make it easier on ourselves. Leave it like that. All right, you guys, so next part, write the equation of the tangent line at x equals 7. So if you remember over here at x equals 7, remember how our line was flat there? That meant 0 slope. And so that's the slope that I'm going to use. And I can use the point 7, 3. It's obvious that that is a point on the grid, so I don't have to use this one or this one, although I could. I'm just going to use the point at 7, which is 7, 3. So that's going to be my point, and remember my slope is 0. So again, I'm going to write what's the point is 7, 3. The slope at x equals 7 is 0. It's a flat line. Therefore, the equation is y minus 3 equals 0 times x minus 7. That gives you y equals 3 when you simplify it. It is a horizontal line. Okay? Over the interval -7 to 6, so between the x values of -7 and 6, less the x coordinates where the g of x has a horizontal tangent. So what you have to think about here in terms of horizontal tangent is if this were a roller coaster and you were traveling from here up to here, at what point do you switch directions, and at what point are you going from down to up in the roller coaster, or from up to down? When does it actually switch is your point. And so what you're going to be looking for here, and this is major calculus, you guys, is that right here we have a horizontal tangent. What we talked about in class is that if I had like a pencil or something, and or my marker that I was using, as I'm traveling along the curve and I'm getting closer and closer and closer to the top of this hump, at the top of the hump the line is flat, the tangent line, and then it starts to decrease. Okay, so there's a spot there, and that looks like the x value of -3. There happens to be another one over here at the x value of +4. So right here again is another horizontal tangent. That's because my roller coaster is decreasing, 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 flat, and now it's increasing again. Okay, and what's weird that you're going to learn a lot more in calculus about is that anytime there is a corner, which a corner would be referred to as right here or right here, a very sharp turn that isn't curved. Here's another corner. Here's another corner. It's not a curve. The corners don't count as horizontal tangents. And so the way that I want you to think about that is I believe that the roller coaster would crash if it went like this and then tried to go up the hump here, okay? So the roller coaster would be just fine, nice and smooth, and a very enjoyable ride on this part of the hump, but it would probably crash right here because it's such a sharp turn that it would not function. Again, this is a really sharp turn. This is very, very sharp. It's not a smooth curve like this is. So we're only looking at curves in this case when we're talking about horizontal tangents, okay? So I'm going to write a couple things about that. Here's over the interval, list the x coordinates. The x values were -3 and 4. Just make a note, no corners. It has to be a nice curve. What is the slope of the graph at x equals -5, -1, 2, and 6? No slope. Those are corners. Again, you'll learn a lot more about that in calculus, but for right now, we're only interested in the curves, not the corners. That's where it's a flat line or a horizontal slope, okay? We'll finish this in class, you guys. Have a great night. Thanks for watching.